Hello, AP-CSP students. Today we are going to focus on algorithms. This is a portion of the create task that you just need to be aware of well in advance before you get started so that as you work on the project, you are ready to complete all of the written responses. If you know about this in advance and you design your program the way you should, then answering the questions is going to be so much more straightforward. So you really don't want to wait till you're done with your code and have a running program to then find out that, oh, I didn't do this the way I should have, or I don't have enough complexity to answer the questions. So we should start by just defining what is an algorithm. An algorithm is defined as a finite sequence of well-defined instructions to solve a problem or perform a task. In computer science, it's usually performing some sort of computation. When you read the create task description, you will notice that there is a portion where it says you are required to independently develop an algorithm that integrates two or more algorithms, and that is fundamental for your program to achieve its intended purpose. This part right here about an algorithm that integrates two or more other algorithms can be where some students get tripped up. They may kind of dive into creating their entire program just command by command, step by step, one thing after the other, without actually designing it in a top-down manner, thinking about what's the main purpose and how can I make sub-functions that help me out in accomplishing that main purpose. So this is really the way you want to think about it, is that you have a main algorithm and then that algorithm calls upon sub-algorithms. For example, in the grade calculator app that I wrote for myself, I could say that the main intended purpose of the app is to be able to predict what a student's average is going to be at the end of the year. So that's the main algorithm. And then underneath that, in order to accomplish that purpose, I have to do three different things. I have to first get the current scores that the student has from the user somehow. I have to get them to enter those scores into the computer. Then I have to take those scores and compute the average grade using a formula. And then I need to update the app's display so that the user can see what the final grade would be. So there's my main algorithm, is just predicting what the student's going to get for the year. And then three sub-algorithms are all working towards that task. So here we have an algorithm that integrates two or more other algorithms. The main algorithm might just be simply three different function calls where it calls this function to do its job, and then it calls this function to do its job, and then it calls this function to do its job. And the main algorithm is just calling other functions to do their subtasks. That would be a good top-down design for that example. So here's what that might look like in the code somewhat. I've just left a lot of things very empty here with comments, but if I had my main algorithm being called display student average, I could have that be a function that simply calls three other functions, and each function does a part of the task, and each function would be considered an algorithm because there'd be more than one thing to do to get the current scores. I would have to go to each of the text entry boxes and retrieve those inputs and put them into a variable. So there would be a sequence of instructions inside of this that counts as an algorithm. And then there would be another sequence of instructions in here to calculate the student average, because I'd have to take like the quarter one score and multiply it by 20%, and then take the quarter two score and multiply by 20%, and then take the quarter three score, etc. Take the quarter one exam score, multiply by 6%, and then finally add them all together. That series of steps would be considered an algorithm. And finally, updating the grade display might have several steps in itself. There might be different places where I want to put out the score and perhaps like reset some of the entry boxes. So that could be a third. You don't have to have more than two, but you must have at least one main algorithm that calls two other algorithms to do their tasks. All right, a few more notes as we talk about this concept of having an algorithm that is complex enough to answer the questions. A couple things I want to caution you against, or just kind of give you some tips. Some people may be tempted to build upon one of those programs we did earlier in the year. For instance, there was a multi-screen app where you just took an interest of yours and you made various screens where you could click on one thing and it takes you to another screen. If you remember the code for that program, there was actually not a lot of computation involved. It was just pretty much a long string of event handlers where you had to identify each, choose good names for each screen, and then basically have an identifier where if you click on a certain object, it will take you to that screen. It just like set screen to a new screen. That kind of thing is good to know that you can do, and you can incorporate that into your app. However, if your app consists exclusively of just switching screens from one to the next based on mouse clicks, that is not going to be considered an algorithm that integrates other algorithms. It's not complex enough. Okay, so second point here. If you do decide to do some sort of multi-screen quiz type app where you just click from one screen to the next, make sure that you also build in some sort of computation to determine the end result. Um, that would possibly count as an algorithm. For example, if you make a variable that counts the number of times a person clicks on something, or if they click on this object, they get this many points behind the scenes, they don't even know it, versus they get, fewer points on that. And then at the end, you calculate something and you produce a result that's different based on that calculation. That would possibly lend itself to being more of an algorithm that you could write about. The Design a Scene project, I would like to encourage you to take a look back at it. You can click on the link here in the third bullet. That was actually a great example of top-down design. And even though the purpose of the program was just to display something on the screen that looked like an image, it was actually a very complex program that we wrote. And we used loops and we used random numbers and we used top-down design where we had functions calling other functions. And it's a really good program to model your design after. So that you have the same idea of a main function that calls other smaller subtasks. Okay, so at this point, I would like you to take a look at another project that is given to us by code.org in their Create Task preparation unit. It's called the Grumpy Cat Exemplar Project. There's a link on this screen that you can click right on to experience the code and the program. I want you to run the program in code.org's environment. You can click run just like we do for our own. You'll see that the code is all there in front of you. I want you to play the game yourself. You'll basically feel like it's very similar to the clicker game that we had created. But make sure that you actually try to win the game and see how long it takes you. But I will give you a little hint. If you click on the pet store and you buy some things, it makes it easier to win the game. So anyway, also examine the code. You might want to examine the code to help you kind of try to win the game easier because you'll know how things are being calculated. But looking at that code is a really good example, and you'll see there's a caution at the top. Do not try to use that game as like something as a kind of jumping off point from to just modify a little bit and try to submit it as your own. This will be another very familiar project to all of the AP readers, but it gives you some good ideas to just see a project. And after you have played the game and examined the code, I would like you to look at the answer in their written response document, the answer to question 2C about the algorithm. Okay, so there's a link on this slide to the project written responses. They have given sample responses to the project, all good for us to take a look at as a good example of what to do for our own project. Okay, so have fun with Grumpy Cat, and for today, just following along with these slides and playing with Grumpy Cat, looking at the code and looking at the written responses, that is your whole job, and I hope you enjoy it. Okay, enjoy your time with Grumpy Cat, and I will talk to you on the next class. Bye.